Okay, last hydraulics homework for Chapter 4, number 11. A stream is to be relocated to allow expansion of a residential area. The stream is currently lined with weeds, and when relocated, minimal stream maintenance will be performed. It was previously determined that velocity constraints would require a design utilizing a stone lining. So that is just all background information that you don't really use. Therefore, relocate the stream as channel lined with 8-inch stone. Use the best hydraulic section to determine the depth of flow, bottom width of the channel, area, and velocity. The discharge anticipated for the channel is 480 cubic feet per second at a ground slope of 0.4% and 1.5 to 1 side slopes. So let's go ahead and find that Manning's N for 8-inch stone. Remember, for any time we've got a stone, if we know the diameter, we can find that Manning's N by taking the diameter to the 1/6 and dividing it by 44.4. So in this case, my Manning's N becomes 0.032. Now I'm going to go ahead and use that best hydraulic section procedure. Remember, I need to get the two variables cm and k, and those are both based on the side slope of that the horizontal leg of that side slope, and in this case it is 1.5 to 1, which means the c sub m value is 0.775 and the k is 0.606. So let's go ahead and write those values down as well. And now what to do with those values, so go ahead back to your best hydraulic section formulas. And we're going to go ahead and find that depth y by taking that c sub m, multiply it by the quantity of the flow rate times the Manning's N divided by the slope square root to the 3/8 power. And then find that channel width by taking that value of y and multiplying it by the k that we got from the table. So let's go ahead and solve for y first. So y is going to equal that c sub m, which is 0.775, times the q, 480, times the Manning's N, 0.032, all divided by the square root of the slope, which was 0.4%, so as a decimal it's 0.004, and that's all raised to the 3/8 power. So that gives us a y value of 6.08 feet. And once we know that y, we can go ahead and solve for the b, because b is just going to be that k factor that we got off the chart times the y. So it's 0.606 times that 6.08 feet. So for that base width, I do get 3.68 feet. So now that I have b and y, I can solve for the area. So remember, our area of our trapezoid channel is going to be by plus my squared. So in this case, 3.68 feet times 6.08 feet, plus that m we had from the table there, 1.5 times 6.08 feet squared. And so that does give me a total area of 77.824 square feet. And now to find that velocity in the end, I'm just going to take that flow rate and divide it by the area. So in this case, I had 480 cubic feet per second, and I'll divide that by the 77.824 square feet, and that does give me a velocity of 6.2 feet per second for that channel.